Thanks for watching the screencast about systems of inequalities. The objective for the screencast is learners will be able to graph the solution to a system of inequalities. So a system of inequalities is a set of two or more inequalities that collectively contain two or more variables. This is much like a system of equations, other than simply that each of the statements that are in that system are inequalities now. So here's an example of a system of inequalities. X minus y is less than 3, and 2x plus y is greater than or equal to 10. So any ordered pair or ordered triple, if there were 3 variables, etc., any set of x, y, z that solves each inequality in the system is called a solution to the system of inequalities. One of the differences that you're going to see here is that we're not going to find one ordered pair that solves these inequalities. We're going to find a whole region of them that solve each inequality. So quite simply, the way to organize this problem is to graph each inequality and then decide which region of that inequality solves both of the inequalities. So this is going to be a lot like what you saw in the screencast 7.1, where you made the inequalities, except for that you're going to make 2 of these on the same graph. So I'll do this one in red. Y is greater than 1/2 x plus 3. I'll do this one in blue. Y is less than or equal to negative 3x plus 5. So for y is greater than 1/2 x plus 3, I know that has an intercept at 3 on the y-axis. I know that a slope of 1/2 means up 1 and right 2, or down 1 and left 2. I also know that's, what kind of line is that? Yes, a dotted line. Good. And I also remember thinking about, if I let x be 0, this would say y is greater than 3. Y is greater than 3 looks like this. So all of this stuff, all the things above the line, should solve this inequality. Maybe I don't want to shade that yet for a reason. If I look at y is less than or equal to negative 3x plus 5, I know the y-intercept for that is positive 5. I know that a slope of negative 3 means down 3, right 1. And I know that I need a solid boundary line here. Whoa. Let's try that again. Third time. There we go. Which way should I shade to solve this? Well, if I let x be 0, I need y is less than 5. I need all the stuff this direction. This stuff. Whenever I think about graphing these inequalities, I always see that the 2 lines tend to create 4 distinct regions. And I'm going to ask myself, which of those regions solves this? So let's see if we can figure that out. It's this part, isn't it? It's this part over here, because I shaded it both in the blue inequality and in the red inequality. So all of this stuff in here is the solution. Now, what else is part of the solution? Well, it's also this boundary line here as a dotted line, and this boundary here is a solid line. So like the boundary of that region, whatever they are, if they're dotted, make it dotted. If it's solid, make it solid. All of this is the solution. Okay, let's try another one. I'll do this first one, I think, in red. Y is greater than or equal to 2/3 x minus 4. Has a y-intercept of negative 4. It has a slope of up 2 and right 3, 2/3, up 2 and right 3, or down 2 and left 3. That's a solid line, isn't it? Well, it's better. Which way will we shade that one? If x is 0, I need y is greater than negative 4. I need all this stuff this way. The other one is slightly problematic, isn't it? It's not solved for y yet, but we can fix that pretty easily by putting negative x on the right side of the inequality. Y is less than or equal to negative x plus 2. Remember, we don't flip this sign unless we multiply or divide by a negative. So this would be the line that has a y-intercept of 2 and a slope of negative 1. Down 1, right 1. And this is also going to be a solid line. And which way should we shade for this? If x were 0, I would get y is less than 2. Y is less than 2 looks like this. So it's this side. Which part of this is double shaded? Which part solves both inequalities? Yeah, it's this part over here, isn't it? Yeah. All of this stuff. Anything in this region solves both inequalities, and therefore is a solution to that system. And what about the boundary line? Well, it's both of those solid boundaries too. From here down to here. There it is. You know what time it is now. Pause the video. See if you can sketch this on your own, and when you think you've got an answer, hit play and we'll check it out. Let's go ahead and make this graph of y is greater than x plus 1. It has a y-intercept at 1. It has a slope of positive 1. So we need up 1, right 1 to find other points on the boundary line. Like so. What kind of line should I make? Yeah, a dotted line. And which way would we shade this thing? I like above. So all the points above that boundary line should solve this inequality. What about for this other one? That one needs some work, doesn't it, before we solve it? Maybe I'll take this 3x and move it to the right side and make it a negative 3x. So negative y is less than or equal to negative 3x plus 2. But then to get y, I really want to divide both sides by negative 1. And if I divide both sides by negative 1, I better flip this as well. So y is greater than or equal to 3x minus 2. Got a y-intercept of negative 2. We've got a slope of 3. And we need a solid line. Where should I shade that? If x were 0, I would get y is greater than negative 2, which is all of this stuff. So which part is shaded, or which part is solved by both? It might be easier to draw the boundary line first here. I think it's all the stuff in here and to the left. So like this part here, and then all the stuff here, and then of course all other things bounded by that. So all of this stuff. All the stuff over here should solve both of those inequalities. Thanks for watching.